and welcome to this webinar on new solar radiation features in SimScale. My name is Dr. Nagman Khan. I'd like to welcome all the attendees to this live event where we'll be talking about some new features in SimScale for modeling and simulating solar radiation. First, let me quickly introduce SimScale. SimScale is a German software company headquartered in Munich, and we have built the world's first production-ready SaaS application for engineering simulation. What that means is our software is entirely hosted on the cloud and accessed from any web browser, and we specialize in CFD, computational fluid dynamics, FEA, and thermal analysis. And we're always adding to these capabilities, for example, the solar features which we're about to release. So why are we here today? Today's application is talking about solar radiation, which has a significant impact on the indoor and outdoor thermal comfort of buildings and cities. Now, SimScale has released a new feature that allows architects and engineers and designers to model the impact of solar gain for more accurate simulations and analysis, especially pertaining to thermal comfort predictions. This might be indoor thermal comfort or outdoor thermal comfort, understanding solar loads, and visualization of solar energy on the inside and outside of buildings. I'm going to hand over to my colleague Ajit, who will give you a live demo of the new solar features. And at the end, we'll have some questions and answers, and we can explore in those Q&A session how you can get started with the new features and how they benefit you on your projects. I'll now hand over to my colleague Ajit for the live demonstration.
Thanks, Nagman, for the general introduction. And this is Ajit. I work as an application engineer here at SimScale. And I've been with SimScale for the past 2.5 years. And I'm going to demonstrate what we are going to release on the basis of solar load and solar loading on internal and external thermal comfort studies. So let's take a look at the platform itself. For the beginners, SimScale is again a web-based simulation tool, as Nagman mentioned, so you can easily access the simulation anywhere in the world by using a simple browser and an internet connection. So you can log on to simscale.com, you can sign up and then start simulating directly inside your browser. So for this particular session, we'll talk about an overview of the platform. So just like other CFD tools, you can do everything on a web-based simulation tool. You can import your geometries. We do support a lot of formats from native CAD tools like SolidWorks, Autodesk, Rhino, CATIA, and etc., which you can import and then start simulating on that. As Nagman mentioned, we do support a variety of analysis types, starting from a simple incompressible analysis for the flow simulations up to conjugate heat transfer, and also certain structural aspects of the simulation also. All right. Now, specific to this session, we are about to release a solar load or a solar analysis type, then which can be again used for the thermal comfort studies, both internally and externally. So this can be reached out by selecting the analysis type conjugate heat transfer. And here under the analysis type, you will see something new called a solar load. So to activate the solar capabilities, you would need to switch on the toggle for solar load, and you will get a solar calculator under your analysis type on the left-hand side of your screen. So what is new to this solar load or solar modeling capabilities is that you can actually import your solar data for your analysis and then start running the simulation for your thermal comfort study. So this can be done in a couple of ways. For example, you might need to give the direction of the sun that you want to analyze for your solar analysis. This can be custom, or you can even select a time and place according to your analysis. So for example, let's go with Munich here. We can select the city and also the date and time of your solar loading. For example, we'll pick the date and also a particular time. And based on the place, date, and time, your solar load or the sun direction will be adjusted according to the weather data that we have. And apart from this one, you can also set the solar load, which can be again divided into direct solar load or diffusive solar load. This is the easiest way. And we do have some fair weather conditions, which means you will get certain other parameters that is involving in the solar radiation, such as the cloud cover fraction, ground reflectivity, apparent solar radiation, and also atmospheric extinction. So based on these parameters that you set and also the location, date, and time, your simulation will be included with the solar load, both on the external and internal side of your geometry. Again, you can also align your geometry based upon the actual or geometrical direction by changing the angle of the north direction. For example, if you have imported your geometry in a particular direction, but you want to align that into a geometrical coordinates, then you can simply give the angle of your north direction, and the solar rays or the sun direction will also change according to that. All right. Let's take a look at one of the setup that we have done. So this is again an office room setup, and we have added the solar calculator or the solar load capabilities to this analysis type. So we have set a particular date and time here and give the fair weather conditions with the following properties or the parameters for the solar load. And here, when you set all these solar capabilities, what you get in addition as an output is, in a general case, you get the thermal outputs like temperature, your thermal comfort parameters, and other flow parameters. But in addition, if you add the solar capabilities, you will get the solar radiation acting on your external and internal faces. This can be actually visualized in a second after the result loads. So you can see what is the solar load on your external faces of your building, and also how it actually affects the temperature internally inside your building. All right. Now, in the post-processing scene, what you're looking at is the internal solar load. So by internal solar load, what we mean is, because we have applied the solar load on the external surfaces, what kind of changes is made, or what is the actual heat load that is being acting inside the system or your domain of analysis. For example, you can see there is a window here. We have applied the solar load, and we can already see that right next to the window, the solar load is acting higher than the ambient temperature. This can easily be checked by inspecting any point at the solar load, and you can see the solar load in watts per meter square. So this will give you a pretty good idea of how much external or additional heat energy is added to the system or your domain because of the solar load. Additionally, what you can also check is the external solar load. So if you have applied your solar load and you want to see what kind of load is applied on your external faces, this can easily be visualized by selecting the external solar load. In this case, you can see the internal load is pretty much constant because we are visualizing only the external solar load. And when you pick any surface on the external side, you can already see 730 watts per meter square is applied on the external faces of your domain. And ultimately, how this affects the thermal characteristics of the domain is, you can check the temperature, and already you can notice that wherever the solar load is hitting, based upon the direction, time, and place, you will get external temperatures which is greater than the ambient temperature. And also, based on the openings of the window, you can see the effects of the shadow and also the effect of external loading due to solar radiation. All right. These are the new features that we are going to release. And at this point of time, if you have any questions, please feel free to put that in the chat box, or we can discuss it over the end of the meeting.
Ajit, thank you for that quick demo of the new solar features. I guess, Ajit, the main advantage of doing this is solar radiation and solar gains do have a significant impact on the indoor environment, for example. And these new calculations will directly impact the comfort metrics. Am I right? The PMV, PPD, as calculated by SimScale.
Yes. Thanks, Ayman, for the question. Yes, that is definitely correct. So, since we have the additional solar gain, which we include into the simulation, this is going to definitely affect the thermal parameters, thermal comfort parameters such as PMV and PPD. So, this is going to be indirect, but because of the rise in temperature due to solar gains, we will definitely see a change in the PMV
Yeah.
and PPD parameters.
Yeah, fantastic. And this is one of the key advantages to anyone watching this. Before, when you were calculating indoor thermal comfort or PMV PPD, there was an option to add a gain, a solar gain or radiative gain. Now what we've done is made it easy to explicitly model the solar gain. And there's several mechanisms that Ajit showed earlier. You can set the latitude, longitude, the sun angle, direction, etc. Or you can manually set the solar gain in watts and watts per meter squared. So now you have more accurate way of modeling the solar gain to impact the indoor environment. And that is also reflected in your comfort calculations, such as the PMV and PPD metrics, which are directly output by SimScale. So this was a quick introduction to the new features coming up. We'll be releasing more information on the new features as and when they're released shortly. So keep an eye out for that. Let's take some questions from the audience now. Thank you, Ajit.
Thanks, Naiman.
If you have any questions, please feel free to post them in the questions pane on GoToWebinar. Great, thank you. Ajit, can you hear me?
Yeah, Nagman.
Yep, fantastic. We have some questions coming in from the attendees, so let's take a few of them. We're also joined by my colleague Ricard as well, who's worked on the solar product. So first question, Ajit, is I guess for someone who's going to be doing solar radiation simulation for the first time, how much more time would it take to set up these new features for a simulation?
Mm-hmm. Sure. I mean, once we are familiar with the actual setup for the thermal comfort study by setting up the boundary conditions, the addition of solar radiation parameters is just going to take a couple of minutes. So as we already saw in this session, I mean, it's just like 2 or 3 parameters, and then you switch on the solar load and then set some parameters, and this will already add a lot of features regarding the solar gain into a simulation. So I would rather say literally it takes around 2 to 3 minutes additional to the actual setup for the thermal comfort study. Yeah.
Yep, that's pretty quick. We've got about 3 more questions. How about this one? How much longer would this take to simulate then? And how many, for example, additional core hours would it consume doing this additional solar radiation simulations?
Mm-hmm. Yeah, that's a good question. I mean, we see that the solar calculator is a new feature that we added on top of what we had for the thermal comfort studies. But in the background, what's happening is like instead of setting up a particular wall boundary condition to your thermal comfort study, we are actually making it easy to set up all the solar parameters. So it's literally just a boundary condition addition in the background or to the physics of the study itself, and the runtime and also the computational power is not going to vary much, although there might be a slight difference between the normal case study without the solar load and with the solar load. So I would rather say, based upon experience, this is going to increase about 2 to 5% of your computation time and also the computational effort or cost.
Fantastic. Okay, we have a few questions about kind of the location weather data. So how is it integrated into the weather database that you use for solar loads, the new features?
Sure. I mean, in the solar calculator, you might have seen, I mean, I can pull back the platform if that should be fine. Nagman?
Yeah, go for it.
Yes. All right. I think the screen should be on. So
Yes.
exactly. For the solar calculator setup, I mean, these are the parameters that you actually set. And as you can see, you can enter a location directly from the geographical data, and then you can locate the date and time of the solar load and give your parameters apart from that. So the weather data is actually linked to the direction of the sun or solar radiation happening on that particular date and time. And this will be effectively integrated. And we do have our product manager, Richard, with us in the call. So he worked on the development of this feature in particular for SimScale. So he can also provide a little bit of information on the background for this. Richard, can you please add some information onto that?
Sure. Can you hear me?
Yeah.
Yeah. So basically, the integration so far, when putting the location inside, defines the angle of the sun, right? So based on the location on Earth and the time and date, what this integration defines is the exact inclination angle of the sun on the particular location and time. What it does not do is take the actual weather conditions, like the sky cloud factor and the apparent solar radiation and so on, from this particular date and time from historic weather data. So that part is not yet part of the integration. It's basically something that the user defines manually, either from some other online resources, from weather files that exist for the specific location, and it's not yet directly integrated as the direction of the sun is. But we are planning on integrating additional features here, for example, to directly upload the EPW file if you have one for a particular location, and then we can take all the data directly from there. So just to sum it up for now, the location and time sets the correct angle of the sun, and for the intensity of the solar load, you have to define manually your conditions, either via the fair weather conditions settings or explicitly defining the diffuse and the direct solar load.
And Ricard, thanks so much for that. Ricard, maybe you can tell everyone why SimScale decided to add the solar features. What was this development based on?
So, I mean, what we already have on the platform is the ability to take into account radiation effects in thermal comfort studies. So the problem was if you have a particular sunny day and the worst case conditions that you want to analyze your thermal comfort factors for a specific room or building or atrium, what we didn't take into account is the directionality of the load coming from the sun in this case, right? So what we could do is we could add previously a specific heat load in watts per square meter on the window, for example, to mimic the incoming additional heat source from the sun. But what this didn't take into account is the directionality of the sunlight. So it was basically a pure diffuse radiative load. So now we can take this more accurately into account and see also what we've seen before, the shading effects, and that locally within the room the temperatures will differ, and hence the local comfort results will be adjusted accordingly.
Good segue into a question by one of the attendees. It's Mr. Dutters asking, in order to compute the comfort, do you calculate the MRT, mean radiant temperature, based on the radiation that lands on the occupant as well? Or is it how is that how is the MRT basically and PMB, PPD affected by the new calculations?
Yeah, so the MRT calculation is currently not updated, in the sense that we still use an approximation of the MRT value, which is non-local. So we have basically a constant MRT value, an approximated one. So a more accurate MRT calculation, I mean, there are many ways how to do that, is on the way. It's not yet included here with this solar gain feature. So nothing changed in that regard.
Yep, great. Maybe you could tell us a bit about what's coming up, additional features to strengthen this solar radiation, and when users might have access to it?
Yeah, so next steps is basically have a proper coupling between surface to surface and the solar radiation, which will be a next iteration that we're tackling in the next months. So probably in 2 to 3 months we'll have this fully released, and that we have a concrete coupling of both mechanisms. And as we also saw, more accurate calculation of MRT is then a next step that we'll take, and also fundamentally in the end, coupling the structure and the fluid in one go, having that a proper CHD analysis together with the solar load and surface-to-surface radiation as a next step. As we see currently, we're still analyzing only the fluid volume, and then once we have the structure integrated, you basically can also directly put the materials of the solids of the chairs and so on, and don't need to set a boundary condition for those.
Okay, fantastic. Thank you. If you have any more questions, please post them in the question panel. In the meantime, I'd like to direct you to some resources on our website. We have a blog on solar radiation. Here's the link. We will include this and other relevant information in the follow-up to this email, to this event. And you can also sign up to SimScale here. Sorry for that. simscale.com/sign up if you want to try SimScale and give it a go. So here's a great new feature for simulating thermal comfort in buildings. What we've done basically is added another layer of accuracy, and by allowing users to explicitly model the solar radiation now in rooms, which we know has a big impact on the room comfort conditions, room temperatures, and various other environmental parameters. So we look forward to everyone trying this. Please look at the resources, sign up to SimScale, and if you have any other questions, we'll stay on the line for another few minutes. Otherwise, thank you for attending.